Hello everyone. In this video lesson, I'm going to discuss about combined gas law. When we say combined gas law, it is the combination of the three gas laws, which are Boyle's law, Charles law, and Gay-Lussac's law. So this time, the only constant would be the amount of gas, which is in moles. Okay, so what will happen, or what will be the value of volume, pressure, or temperature of a gas if there will be change? Again, the only constant is the amount of gas. So here in our simulation, we have our fixed amount of gas here. And watch what will happen if there will be change in temperature. Watch what will happen in our volume here and here in our pressure. Okay, so initially, okay, in our simulation, we have this temperature of gas, which is 10 Kelvin. For volume, we have 150 liters, and for the pressure, we have 0.33 atmospheres. So watch what will happen if temperature will change. Okay, observe what will happen in volume and pressure. So let's change the temperature here by increasing the temperature. Okay, volume increases. Okay, and pressure is also increasing, but suddenly, okay, as pressure increases, volume decreases. Okay, but the temperature here remains the same now. Okay, so let's say, for example, let's lower the temperature now. Watch what will happen if we lower the temperature. Okay, temperature is decreasing, pressure is decreasing here, volume is still the same. Okay, all right. So let's have another more presentation of it. So let's increase again the temperature. Okay, increasing temperature, increasing volume, increasing pressure. However, okay, suddenly the volume drops as pressure increases. Okay, so those are some of the things that you might observe if the only constant, okay, is the amount of gas, and temperature and volume and pressure are changing. Okay, so when we say combined gas law, again, these are combinations of these three gas laws. Okay, we have Boyle's law, Charles law, and Gay-Lussac's law. So in Boyle's law, here you can observe the relationship between pressure and volume of gas, okay, at constant temperature, okay, and of course fixed amount of gas. Here for Charles law, relationship between volume and temperature of gas. Okay, and here for Gay-Lussac's, we have the relationship between pressure and temperature of gas. So if we will describe the relationship of the properties of gases here, so for Boyle's law, what we have here is pressure. Let's have, okay, for pressure, again, it is inversely proportional, okay, to volume. Okay, it is inversely proportional to volume. What does it mean? If pressure increases, okay, volume decreases, and vice versa. If volume increases, okay, pressure will decrease. Again, that can happen only if the temperature and the amount of gas are constant. Okay, so here in Charles' law, what we have is a directly proportional relationship, okay, between volume and temperature of gas. Okay, so what do we mean by that? So volume is directly proportional to temperature. Okay, again, constant pressure. Okay, and of course, same amount of gas. For Gay-Lussac's law, it is directly proportional also for the relationship of pressure and temperature. Okay, so the relationship between pressure, okay, and temperature is directly proportional. Again, this time the constant are the amount of gas and of course volume. Now from this, okay, from this understanding, we can actually, okay, combine these three gas laws in a way that the only constant would be the amount of gas. Okay, so let's have that we can use this idea, any of this, okay, to show that even though we combine these three gas laws, we still have, we can still see their concept. Okay, So let's use this one here, okay, this Boyle's law equation here to show or derive the combined gas law equation. So let's say, for example, okay, pressure, okay, is directly proportional at K constant, okay, over volume. And again, in Boyle's law, the constant, okay, the K constant in Boyle's law is of course temperature and amount of gas. Okay, so we can replace it here. Okay, pressure, okay, is equal to, okay, temperature times the amount of gas in moles over volume. Again, let's have the K constant here is the amount of gas, which is the represented by this N here. So let's just replace it here. Let's replace by this symbol, okay, this one, K. So again, the only constant would be the amount of gas. So we can simplify this where pressure, okay, times volume over temperature, okay, is equal to K constant. Okay, so no matter what will happen, okay, if there's change in pressure, volume, or here in temperature, just what you observed from our simulation a while ago, okay, there's no change when it comes to the amount of gas. This remains constant. Okay, so let's have this as our initial volume, initial pressure, initial volume, and initial temperature. And again, if there will be change, it's the same also. We have our final pressure, okay, of a gas, final volume of gas over the final temperature of gas. Okay, again, that is still equal to the K constant, which is actually the amount of gas. So since initial observation is equal to K constant, even our change or our final observation is equal to K constant, then definitely we can say, okay, we can have this combined gas law equation where, okay, P sub 1 times V sub 1 over T sub 1 is equal to T sub 2 or final pressure times the final volume over final temperature. Again, the unit of the temperature here must be in Kelvin. And as you can see, as what I've said, okay, since we combine the three gas laws, you can still see it here. Okay, here is your Boyle's law. So you can see this is our Boyle's law here. So we can still see Boyle's law here. Here is our Charles law. As you can see, this is our Charles law. And this is our Gay-Lussac's law. Okay, so again, our Boyle's law, Charles law, and of course, Gay-Lussac's law. Okay, so let's use this combined gas law equation in some problems. Here is a problem. So we have a gas has a volume of 800 milliliters at negative 23 degree Celsius and 300 at 300 torr, and of course, what would the volume of the gas be at 227 degrees Celsius and 600 torr of pressure? So we will assume that the amount of gas is fixed or constant. So here are the given, here are the known facts about the problem. So we have our initial volume, which is 800 milliliters. We have the initial temperature, which is negative 23 degrees Celsius. But here we already converted it into Kelvin, which is we add 273.15. So we have 250.15 Kelvin as our initial temperature. For our final temperature, we have 227.0 degrees Celsius. Converting that into Kelvin, we have 500.15 Kelvin. Again, in any gas law problem, if you will be substituting or using the temperature, the unit must be in Kelvin all the time. It must be in Kelvin. And for our initial pressure, we have 300.0 torr, and then for our final pressure, we have 600.0 torr. So in this problem, we know that we will be using the combined gas law. So we will assume constant yung amount of gas. So we're looking for the final volume. Okay, so this is our equation. So let's derive our equation since we're looking for the final volume. Okay, so we have here, okay, initial, okay, pressure times initial volume over initial temperature is equal to, okay, final pressure times final volume over final temperature in Kelvin. So again, ito yung hinahanap natin, yung final volume. Okay? So what we're going to do is we're going to move, okay, this final temperature here, okay, on this side, and the final pressure here. So our derived equation would be, okay, final volume is equal to initial pressure times initial volume times final temperature of the gas over initial temperature times final pressure. So ito yung gagamitin nating equation ngayon since we're looking for the final volume. Before you substitute the values or the given here, check nyo lagi yung unit. Okay? So wala tayong problema sa unit ng pressure, parehas na naka-torr. Yung ating temperature, parehas na nasa Kelvin unit na. So, our final volumes unit will be in milliliters. Okay, so we can now substitute. Okay, so we have here our values now in our derived equation. So let's multiply first. So, our final volume is equal to, okay, so multiply muna natin. Okay, so 300.0 times 800.0 milliliters times 500.15 Kelvin. So we have here 120 million. Okay, let's have, sulat natin dito, 120, okay, 36, okay, million. So this is the product of the initial pressure, volume, and the final temperature. Okay, and of course for our denominator we have 250.15 Kelvin. Multiply it to the final pressure, which is 600.0 torr. So the product is 150,090. Okay. Yeah. So obviously in our here makakancel yung unit na torr, okay, or pressure, at makakancel din yung unit na Kelvin. So ang matitirang unit ay yung milliliters. Okay? So kunin na natin yung ratio nito. So 120.36 million divided by 150.90. Okay, so our final volume, okay, is equal to 799.0 0.8, okay, milliliters. Okay, so this is our final volume. Let's have another example problem. So here we have a balloon of air, okay, now occupies 10.0 liters at 25.0 degrees Celsius and 1.00 atmospheres. So what temperature was it initially if it occupied 9.40 liters and was in a freezer with a pressure of 0.939 atmospheres? So again, let's identify our given. So we have our given here. We have the initial volume, which is 9.40 liters. Our initial pressure is 0.939 939 atmosphere. And of course, for our final pressure, we have 1.0 atmosphere. For our final temperature, it's 25.0 degrees Celsius. Converting it to Kelvin, it is 298.15 Kelvin. And of course, for our final volume, it is 10.0 liters. So what we're looking for is the initial temperature. Okay, the initial temperature. What was the initial temperature? Okay, so we will assume that the amount of gas is constant or fixed. So we will be using the combined gas law equation here. So since we're looking for the initial temperature of the gas, we will derive the equation here. So let's have P sub 1 times the initial volume over the initial temperature, which is equal to the final pressure times the final volume over the final temperature. Okay? So since ito yung hinahanap natin, okay, mag-exchange tayo. This will be exchanged here. This will be put here. And the final temperature will be placed here. So our derived equation will be initial temperature is equal to initial pressure times initial volume times final temperature over the final pressure times the final volume. So, before nyo i-substitute or ilagay yung mga given, check nyo muna yung mga units kung okay, kung parehas. So, atmosphere, naka-atmosphere yung unit ng ating pressure. For our volume, both naka-liters. And of course, our temperature is in Kelvin. So, let's substitute now our given here. So, our initial temperature is equal to, let's have our 0.8939 atmosphere. Okay. And for our initial volume, it is 9.40 liters. For our final temperature, it is 298.15 Kelvin. 298.15 Kelvin over the product of the final pressure, which is 1.0 atmosphere, okay, times the final volume, which is 10.0 liters. Okay, 10.0 liters. So, clearly, dito sa ating process, makakancel yung ating unit sa pressure at yung unit sa volume. So, ang matitirang unit lang ay yung units para sa temperature, which is in Kelvin. So, first, let's get the product of this. So, let's have, okay, the product. So, 0.939 times 9.40 times 298.15, that is equal to, let's write it here, yung product. So, we have 2631 point. Sulat natin lahat na nag-appear dito sa calculator para mas maraming significant figures, mas accurate. Okay? And of course, let's divide it here. Okay, so that's simply 10. No, 10.0. Okay. So 2631.65079 divided by 10.0. Our initial temperature in Kelvin, initial temperature or the original temperature is equal to 263, okay, Kelvin. Or if we will convert this in degrees Celsius, our initial temperature in degrees Celsius, so isubtract lang natin yung 273.15, so i-minus lang natin, 273.15. So our initial temperature in degrees Celsius, or the initial temperature in degrees Celsius, is equal to negative okay, 10 degree Celsius. Okay, so this is the initial temperature, okay, in Kelvin or in degree Celsius. So combined gas law can be used only if constant yung amount of gas, fixed yung amount of gas, and the variables that are changing are the temperature, pressure, and of course the volume of gas.